Hello and welcome back to my channel. Today in this video we are going to discuss the last few questions from May-June 2021 Pure Mathematics 1 solutions, and it is 9709. The component is 13. So let's start with the question number 8. Function f and g are defined as follows. Fx is given as x square minus 1 for all x less than 0, and gx is defined as 1 over 2x plus 1 for x less than minus 1 by 2. So first part is solve the equation f g x equals 3. So first of all we will find the composite function, then we will make it equals 3, and then we will solve that. So here we can see f g x is f of g of x. So in place of gx we will write 1 over 2x plus 1 as the input for fx, and we know the function f gives the square of the input and subtract 1 from that. So input is 1 over 2x plus 1, so it is 1 over 2x plus 1 whole square and minus 1. And since we are going to solve equals 3, so this is going to be equals to 3. And now we will simplify it. It's better to send this minus 1 to the other side so that it will become 1 upon something equals 4, and it would be easy to take the square root. We have two options: either we multiply, cross multiply and take the open the bracket and then solve it, but it's better if we have only two terms, then we should take the square root. So I took the cross multiplication and I got 1 upon 4 as 2x plus 1 whole square. So removing the square we get 2x plus 1 equals plus minus half, because the square root of 1 by 4 is half. So by taking plus sign we get 2x equals minus 1 plus half, that is minus half, and by taking negative sign 2x becomes minus 1 minus half, that is minus 3 by 2. So we got two values, that is solutions. X equals minus 1 by 4 and x equals minus 3 by 4. But for gx, x is less than minus 1 by 2. So for f gx, the input is gx, and gx is only defined when x is less than minus 1 by 2. So we can see minus 3 by 4 is here and minus 1 by 4 is here. So it cannot be minus 1 by 4 because minus 1 by 4 is bigger than minus 1 by 2. So the solution will be only minus 3 by 4. So we have to ignore minus 1 by 4 in this case. And here's the B part. Find an expression for f g inverse x. Or from A part we can see f g of x is 1 over 2x plus 1 whole square minus 1. It's a good practice if we start from the finding the inverse from here only. And if we are going to take the LCM and then open it and make it as numerator and denominator, it would be very complicated. So it's better to make this as y, and then we got this function, interchange x by y and y by x, we got this. And now in order to find the inverse we will make y as a subject. So the better thing is minus 1, we will send it here. We got x plus 1 equals 1 upon 2 plus 2y plus 1 whole square, and then cross multiply we get 2y plus 1 whole square equals 1 upon x plus 1. So this will go down, and then again there is a square, so you will take the square root, and hence we will get 2y plus 1 equals plus minus 1 over root x plus 1. First of all we have to decide whether we are going to take plus or minus. So altogether we got y as minus 1 by 2, sending minus 1 this side become minus 1, and sending this 2 in denominator we got minus 1 by 2 plus minus 1 upon 2 root x plus 1. Since range of f g inverse x we need to find, because we are going to calculate find whether we need the plus sign or minus sign, we will take the range of f g inverse. And we know range of inverse function is same as the domain of the function, and domain of function in this case is f g x. And f g x, for this we have to focus on the domain of gx. That's how we decided in the last part which value of x we have to ignore. And for f g x to be defined we need to see the domain of gx, and that is x is less than minus 1 by 2, it is given. So it has to be this y, the inverse function has to be less than minus half, and for that we have to take only minus sign, not plus sign. So finally we got y equals minus 1 by 2 minus half root x plus 1. So we can write fg inverse x as minus 1 by 2 minus 1 by 2 root x plus 2 root x plus 1. Here's the ninth question. A geometric progression is such that the second term is equal to 24% of the sum to infinity. Find the possible values of the common ratio. So it gives the hint, we can say, the possible values, so we can have more than one values of common ratio, that is r. So here we have GP, and in GP we have AR square, AR cube, and so on. And sum to infinity is a over 1 minus r, where r has to be in between 1 and minus 1. Because if r is greater than 1 or less than minus 1, so it would be an infinite sequence. If you add, we will get either minus infinity or we will get plus infinity. So that's why it has to be in between minus 1 and 1. So here the condition, second term that is going to be AR, and it is 24% sum to infinity. So 24% we can see it is 24 by 100 of sum to infinity, and sum to infinity is a over 1 minus r. It's little bit algebraic, but that's fine, because next thing we are going to cancel it, and we will get 25 times 1 minus r into r equals 6, because a got cancelled. So we got quadratic equation. We'll simplify in the same we write in the standard quadratic form, and then we can find the two terms. We can see 25 into 6 is 150, and minus 15 minus 10 is going to be multiplied and get 150. So we can factorize them like that, and we get one factor as 5r minus 3, another as 5r minus 2. So this equals 0, means they individually have to be 0. R is either 3 by 5 or R is 2 by 5. That's how we get the two possible values for R. That's the common ratio. And here's the B part. And arithmetic progression P has first term A and common difference D. And arithmetic progression Q has first term 2 times A plus 1 and common difference D plus 1. It is given, this is the condition. Fifth term of P and 12th term of Q is 1 over 3. And sum of first 5 terms of Q, P, and sum of first 5 terms of Q is 2 by 3. And we need to find the values of A and D. So we'll go with the condition. First condition, since we have the first term and common difference, so we can use A plus 4D upon 2 times A plus 1, that is A for the Q, first term of the sequence Q. 11 times because 12 minus 1 11, and then D plus 1 is the common difference. This is 1 by 3. We simplify, we get 2A plus 2 plus 11D plus 11 equals 1 by 3. Cross multiply, we get 3 times A plus 4D, and we simplify here, 2 plus 1 11 plus 2 is 13, so 2A plus 11D plus 13. So this is what we got as the first equation. We will simplify, and we will get this thing as 2A plus 12D equals 2A plus 11D plus 13. If we simplify, sending this thing here, 3A minus A is A, 12D minus 11D is D. So it is 13, first equation. And from the second condition, we can see second condition is sum of the first 5 terms. So 5 by 2, 2 times A plus 4D. And sum of first 5 terms of Q. For Q, first term is 2 times A plus 1, and common difference is D plus 1. So it is 5 by 2, 2 times 2A plus 1, and 4 times D plus 1. So it is equals to 2 by 3 given. Now we will simplify this. 5 by 2 got cancelled. This 2 we can take common from the numerator. We got A plus 2D, and we can take 4 common from the denominator. We get A plus 1 plus D plus 1 and equals 1 by 3. This 2 got cancelled with this 2, and then we do the cross multiplication. I have written it again. A plus 2D upon 4 times A plus D plus 2 equals 1/3. And if we cross multiply, we got A plus 2D into 3, and 4 times this all we got here. So when we simplify from here, we get 3A plus 6D equals 4A plus 4d plus 8, and we will send this constant here and the a and d terms here. We got 4a minus 3a is a, minus plus 4d minus 6d is minus 2d. So we got another linear equation. So we got two linear equations. First one is a plus d equals 13. Second one is a minus 2d equals minus 8. We can see a have the same coefficient. So changing the sign, we got d plus d 2d 3d equals 21. So d is 7. And when we substitute this d value here, we get a plus 7 is 13. That is a equals 6. So we got first term and common difference of the term. First sequence p is 6 and 7. Here's the 10th question. Points a as minus 2 comma 3, b as 3 comma 0, and c as 6 comma 5 lie on the circumference of the circle with center d. Center is given as d. Show that the angle ABC as 90 degree. We have so many methods. We can talk about the gradient of AB and gradient of BC, and if their product is minus 1, so it is going to be 90 degree. Otherwise, we can simply find AC distance, AB distance, BC distance, and we see if they follow the Pythagorean triplet condition, then also it is going to be 90 degree. So first of all, we will find AB square. AB square is 3 minus minus 2. You can see 3 minus minus 2 plus 0 minus 3 whole square. We got this as 34. Similarly, BC, C that is 6 minus 3 whole square plus 5 minus 0 whole square. We got 34 again. And AC square is A to C, 6 minus minus 2 whole square, 5 minus 3 whole square. We got 64 plus 4, that is 68. And this is what we can see is 34 plus 34, that is AB square plus AC square, and hence the angle ABC is 90 degree. I believe the another one would be easier to do, because we can simply find the gradient of this, we can find the gradient of this, and we can see the product would be minus 1. So 0, or we can say 3 minus 0 minus 3 is minus 3 upon 3 minus minus 2 is 5, and the gradient here is 5 minus 0, 5 upon 6 minus 3 is going to be 3. See, they are negative reciprocal of each other. That's also be a best way to find out whether they are going to be a right angle triangle. Angle ABC is 90 degree, and hence state the coordinates of D. So once we have angle ABC as 90 degree, we know that AC has to be a diagonal, a diameter, and the center lies on at center is the midpoint of the diameter. So D is the midpoint of AC. We have all the coordinates. We simply find the midpoint, and that is going to be D equals 2, 4. In the C part, find an equation of the circle. We have the center 2, 4. Radius is AD. We can see from here D coordinates we have, A coordinates we have. We can choose any other alphabet, any other points like B and C, but it's fine. AD, we have D as 2, 4. So radius AD is 2 minus 2 whole square plus 4 minus 3 whole square. Or otherwise also we could have, as we have AC square here, we can take the AC and half of it. That's also fine. That would be the radius. But it is root 17 anyway, and equation of circle is x minus h whole square y minus k whole square equals radius square. So it is x minus 2 whole square plus y minus 4 whole square equals 17. Now here's the second last part. The point E lies on the circumference of the circle such that BE is the diameter. Now D is the midpoint of BE, we know, because it is going to be, since it is going to be diameter, we need to find the equation of tangent to the circle E. We need to find a tangent, equation of tangent at E. Let's say this is the line, this is a tangent. So for tangent we need gradient, we need a point. So for the point, what we can see here is D is the midpoint of E and B, and since it is a midpoint, so sum of the x coordinate divided by 2, x plus 3 divided by 2 will be 2, because that's the x coordinate of 2, D, and y plus 0 divided by 2 would be the y coordinates of 4. So from here we can get x and y coordinates of the E. So we got coordinates of the E, from where we are going to find the equation of tangent. So point is done. Next is the gradient. Gradient of tangent would be negative reciprocal of the gradient of BE or DB, whatever, because that's the gradient of this line, and they are going to, we know that angle between the radius and the tangent at contact point is 90 degrees. So we'll find the gradient of tangent at E as by -1 over gradient of BE, and BE gradient is B, we can see 8 minus 0 and 1 minus 3. So we got this as 1/4 after solving, and since we got the equation gradient and the point on the tangent, so it is y minus y1. y1 is 8 equals 1/4 of x minus x1, that is 1. So we simplify, and finally we can write our answer in the form of this: x minus 4y plus 31 equals 0. Here's the last question of this paper. The diagram shows part of the curve with equation y equals x to the power half plus k square x to the power negative half, where k is a positive constant. Find the coordinates of the minimum point of the curve, giving your answer in the form of, in terms of k. So for minimum or maximum, we know that we are going to find the differentiation, and then we will make it equals to 0, and we will find the x value. So here for minimum point, dy over dx is 0. First of all, we will find dy over dx, and that is half times x to the power half minus 1 minus half minus k square times minus 1 by 2 and 3 x to the power minus 3 by 2. This is 0. And the next thing is how we solve it. We can solve in any way. There are so many ways, but I prefer, like, if the power is positive, then it would be easier to get rid of this power thing. So we can take it in the denominator. It becomes x to the power half, again k square upon 2 to the power x 2 into x to the power 3 by 2 equals 0, and then there is a one term and equals to 0, so I send this to the other side. We got 1 upon 2 x to the power half equals k square upon 2 x to the power 3 by 2, and 2 got cancelled, cross multiply, we got x to the power 3 by 2 equals k square into x to the power 1 by 2. We can take the cube of both the side, or sorry, square of both the side. We got x cube here because this root got cancelled, and k to the power 4 and x, or we can take one side, x cube minus k power 4 x equals 0, x common, x square minus k power 4 equals 0, x is 0, or going to be the another thing is x is plus minus k square, because k power 4, square root of k power 4 is k square, and hence we got x equals to k square, because we can see from here this minimum point is lying on the positive side of the x-axis, so it cannot be negative. So from here we got x coordinate k square, for y coordinate, because they ask us to find the coordinates of the minimum point of the curve, so we need to find both the coordinates. For y we have this is the curve equation given, x power 1 by 2, because x is k square, so x power 1 by 2 would be of course k, and then k square is there, and negative x to the power negative half means 1 upon x to the power half, and again it is k got cancelled, and there is going to be 2k. So stationary point is, or minimum point is going to be k square comma 2k. And for the second part, the tangent of the point, tangent at the point on the curve where x equals 4k square intersects the y axis at p. Find the y coordinate of p in the terms of k. So I have drawn it. If we have 4k square here, so at this point we got to the curve, we draw the tangent, and then we got this point as p. So we need to find the y coordinate of this p, because we know the x coordinate is going to be 0. So from part A we know that dy over dx. Why we require dy over dx? Because since it is given, it's a tangent. So for tangent we require anyway dy over dx. So dy over dx we have from the first part, and then gradient of the tangent at x equals 4k square. We are going to find the gradient of the tangent at this point, so we'll simply substitute x by 4k square. That is going to be this minus k square upon 2, 4k square, and minus 3 by 2. And then it is 4k square negative, so we'll make it positive by sending it in the denominator, and then we can do the simple calculation. This is 2 because square root first of all, and k square become k, and then cube is there, and here it is square root, so 2k outside, and 2 into 2 4 and k 4k 1 upon 4k and k square, and when we take the cube now it is 8 times k cube, 1k got cancelled, and finally we got 1 upon 4k minus 1 upon 16k, and this is going to be 3 by 16. And at x equals 4k square, why we are doing this? Because once we got a gradient of the tangent, now we need to find a point on the tangent so that we can simplify. While finding the equation of tangent, we can put x equals 0 and we get the y coordinates of the p. So at x equals k square, we'll substitute k square 4k square here, and we got 5 by 2k. It's easy to calculate. And then equation of tangent we'll find by y minus y1 is this 3 by 16k, that is the gradient, and x minus 4k square, 4k square is the 4k square is the point. And on y-axis we know x is 0, so we can simply substitute here x is 0, and then we got minus 3 times 4k square upon 16k, and 5 by 2k will come this side, it becomes positive. And then it is 5 by 2k minus 3 by 4, because k square, this 1k got cancelled, 16 and 4, so 3 by 4 times k, and finally we got 7 by 4k, and that's the y coordinates of p. Yeah, here's the last part, C part. Find the area of the shaded region in terms of k. So we know area is going to, we are going to get the area by integrating the curve, and it is the easiest one because we have both the limits of the integration, 9 by 4k square to 4k square, and we have this curve equation as well. So it is, area is going to be from 9 by 4k square to 4k square y dx. So y putting here, and then x to the power half, so x to the power half plus 1, 3 by 2, divide by 3 by 2, plus k square constant, x to the power minus half plus 1 is plus half, divide by plus half. And then we can simplify again, and we can see it is 2 will come in the numerator, so we take it out, and we are left with x to the power 3 by 2 upon 3 plus k square x to the power half. Now we'll put the limit, upper limit first, x is 4k square, so 4k square power 3 by 2 upon 3 plus k square 4k square to the power half, and then we got it as 1 by 2, lower limit, 9 by 4k square to the power 3 by 2 plus k square 9 by 4k square to the power half. And we are going to take the square root, and in this case the first part we are going to take the square root, then we take the cube. So 4k square root is 2k, cube is 8k cube upon 3. 4k square root is k, 2k, and k square by multiplied by 2k become 2k cube, minus here again square root of this is going to be 3 by 2k, and then cube of it is going to be 27 by 8 k cube, and then we can cancel this, 3 by 27 by 3 it is 9, and here it is again square root, so 3 by 2 k, and then k square multiplying to, so it becomes k cube. So we can see now it is going to be, everywhere there are k cubes, so we will simplify one by one. This we simplify these two, we got 14 by 3 k cube, we simplify these two, and then we got 21 by 8 k cube, and we subtract it and then multiply by 2, we got the final answer as 49 k cube upon 12, and that's the area, unit square we can write at the last. So that's the solution of this paper. I hope it was of some help. We'll meet again in the next paper, solution of the next paper. Till then, thank you so much.